Hello folks, this is 2023 February March session, paper 1-2, and the question number is 6. This question is concerned about the chapter kinematics as is shown by the graph here. It says the graph shows the variation with time t of the displacement s of an object. So time t here in the x-axis and displacement x in the y-axis. Which graph represents the variation with time t of the acceleration a of the object? So we have to find the variation of acceleration with time. So let me draw a timeline here like this. So this is the timeline, and let me draw the graph of velocity right below this. So this is the axis, and this is the velocity here. Now we know that the value of v is given by slope of st graph. So here the graph is a straight line with a positive gradient, and the gradient is positive, constant, let us say. So that means v should be, slope is constant, positive. So that means slope is a constant and positive. So that means we also should have a constant and positive value. So from here to here, the value of v should be like this, from here to here. Now here the value is constant and negative. So in this region the value is constant and negative. So the value of v should be constant and negative here, and this value, so this value and this value should match because the slopes are same, only the sign is different, positive, negative. Now from here to here, it has to go from here, so it should go like this. Straight line which is vertical. Now again here the same case repeats, so the value of v should be like this, and here same case repeats, so the value of v should be like this. So that means it rises like this, it falls like this, and so on. Now with this we can guess the graph of a as well. So here now again what we have is a equal to slope of vt graph. So here we have v is a constant stuff here, which means the slope is 0. Constant means slope is 0. Slope 0 means a should be 0. Now if I go through all the graphs, here a changes, so it does not qualify. Here is negative, doesn't qualify, and here is positive, it doesn't qualify. The only qualification is number t. So here a is 0 0 0 0 here, so a is 0 0 0 here, and then here a is the value of velocity is constant and negative, so a should again be 0. So again a should be 0. But during this time interval, the slope is infinite. During this time interval, the slope is equal to negative and infinite. So that means the value of a there should be negative and infinite. For that very small time interval, the value of a should be negative and infinite, which is happening here. So we can extend it anywhere. So the value of a becomes negative and infinite for a moment, 0 again. And here the value of v is again constant, so a is 0, and the slope here is positive and infinite. Slope is positive and infinite, so that's why the value of a becomes infinite for a moment. So the same process repeats and the graph should be like this. So this is a bit tough type of question, but still it is worthy of tackling.